matrix will always be same. This is also unique observation. So, you need not go means scared ki when it will be a large figure, then we require a large matrix to transform. It is not like that. This 2 by 2 matrix will transform any point, and all these points constitute a object. Now, coming back to the effect, now what is happening? Abruptly these shapes are changing, is not it? This triangular shape is changing abruptly, and you do not know that what element of this matrix playing what role. So, this is one thing, this A and D, matrix A and D matrix A and D helps in scaling. You can write down in your note A and D, sorry, A and D, this main diagonal, this is called main diagonal. Main diagonal helps in scaling. Okay. So, A and D is 1 and 1 and these two is 0 and 0, then it is called identity matrix, and identity matrix will not change any shape, because anything multiply with 1 it will be 1 that number only. So, it will not change any shape. So, whatever triangle you have formed, you just put here instead of A 1, instead of D you put 1 and C 0 and B 0, you will get a there will be no change, it will a superimposed triangle with the original triangle. Tried? Nilay?
Yes, sir.
Raise hand. 1 1 0 0, it is superimposing same.
Yeah.
So, this is the thing. So, A and D is for scaling. A and D, main diagonal is scaling, and how it will scale? If A is less than A and D is less than 1, it will compress, and if it is more than 1, it will enlarge. So, you put 0.5, 0.5, you see this your triangle will become half or 0.25, quarter, it will be quarter. If we put 0.5 here, A is 0.5 and B is 0.5, I think this is 0 and 0, it will be 0.25 in size. Are you getting? It is coming like that, triangle becoming smaller. So, this a small piece of information you can do anything. So, compression is, and when A is equal to D like that, it is called uniform scaling, uniform scaling. If you put 0.5 here and it will 5 here, then x axis will increase 5 times, y axis will decrease 0.5 times. So, it will be a distorted figure again. So, in future there will be no confusion about scaling. Anything you can scale, and scaling only require 2 by 2 matrix, and diagonal elements are responsible for scaling. But another thing, with this you can, if it is -1, suppose A is -1 and this is 1, what will happen? Then x will be changing to negative value, no? When x negative value, what will happen? It will go to the other coordinate quadrant, sorry, this is the point, it will come here, no, x is, if it is x and x equal to 3 and 2, it will be minus 3 and 2, you can check it. So, this is reflection about y axis. If you want to get a reflection about y axis, you just change the first element a as minus 1, that is all. If you want that let it reflect through x axis, you just change the values to here minus 1, make d as minus 1, it will flip towards fourth quadrant. When finished, raise hand. So, I will know that you have finished. Yeah, very good. Raise hand, yeah, but I want others' hand should be raised faster because he is a fashion technologist. He had a what I should say, imaginary shapes and things. Now, it is a deterministic shape, you can create it in through mathematics.
But the process is reverse. Usually what happens, I draw a shape and then figure out if it is possible. Here it is reverse. If it is possible, only then it will form.
Here every shape can be possible, only you have to dream.
No, there I have to dream. I can draw a triangle and then I can measure it. Now I have to know the measurement of a triangle so that I can draw it.
Okay, both way we can do that, we will learn how to do that. And what will happen if we put both minus 1, a minus 1 and d minus 1, it is reflection through a plane from origin, y axis. Okay. So, very simple this reflection. Now, coming back to the next thing is shearing. We had shearing. Okay. For shearing, what we will do, this A and D having no role, this main diagonal do not have any role, this A, C and B having the role for shearing. Shearing, B and C will help in shearing. This is called off diagonal. Earlier A and D is main diagonal, B and C is off diagonal. Off diagonal is responsible for shearing. Okay. So, you see this by 2 by 2 matrix, with that 4 elements you have scaled, you have reflected, you have done shearing. Okay. And neither this increasing with number of points, transformation as matrix has not changed, and at the same time for getting different transformation also, transformation matrix not getting changed. That is same matrix, only 4 element matrix. And then
when you are doing your just scaling the diagonal main diagonal elements, there is a element of translation also happening there.
No, it is shifting, but it is not translation. I will come back to you. Why it is not translation? These are the confusion actually we have, but you will get clarified how why it is shifting. It is the vector is shifting, Vector is increasing. So, vector increasing means
size increases.
size is increasing, that is not scale actual.
But if you look at the triangles themselves, earlier it was at this point and now it is moved to a different point.
Yeah,
That's
that
what.
scaling actual it is not, it is enlarging.
The entire space is enlarged.
Yeah,
Okay.
translation will cover later. So, now coming to the rotation, again it is a good thing that you do not require any other matrix for rotation. This same 2 by 2 matrix will help in your rotation, and how you will do that? Rotation having some special requirement. Can anybody say what is that special requirement?
Axis rotation should be.
No, I think the parallel lines remains parallel kind of thing. Rigid rotation, is it?
Okay, it will remain parallel, no?
Right.
I need not think for that.
And
needs
then
a
the
center.
angles
It needs a center.
A center, yes, yes, it is.
and the angle between the lines remain the same if you rotate.
Angle between the lines will remain same. Okay. Any other? Can you think about rotation? What is the special requirement? Parth, can you say something about when you rotate something? What is the special requirement there?
You can't distort the image.
That should be, that will not restored. But what you will do for that?
We need a degree about which it is rotated.
Point about which you are rotating.
Axis of rotation.
Yeah, axis. Otherwise, it will not rotate. We want degree. Anything others?
Fixed point and degree.
Yeah.
Fixed point and degree.
Fixed point and degree. Yes, you are right. Means what you mean to convey, that is right. I think every point should have equal displacement at some degree. Means x will move 2 degree, then y has to move also 2 degree. Otherwise, it will be distorted, no. So, all the elements should move at a same rate. So, it will be dependent on some parameter which is common to all elements. Otherwise, this is I am now for scaling, what I am doing? I am changing only this, I am not changing this. So, what is happening? Non-uniform scaling is happening. But for rotation, everything should rotate, every point should change at a same rate. How we can achieve that? And it appears when you go for this analytical method, no, this formula will be very complicated. It looks to be complicated, it is not that complicated, but here you can when you will see here how easily it can be achieved. Here A, now I will remove this. This formula we learn from the childhood means class 9 onwards when we introduced trigonometry, but now we will apply that.
Cos theta.
Yes, you are right. This is the matrix. So, this is also a 2 by 2 matrix, means for rotation you need not require any other form of matrix, but matrix is 2 by 2 matrix, but values are changing at same rate. At what rate? Now, that is dependent on t. What is the t? The angle.
But angle over here specified in radians.
All radians, that is also a unique thing to remember. In computer specifically if you do not tell, it will take every values as a radian. Okay. If you want to calculate in degree, you have to get a special command or a special requirement will be there. So, here we will rotate our triangle with a matrix multiplication. How we will do? I told T should be same for all. First you change these cells and arbitrarily in one cell you take T value, suppose you take pi by 4. Pi I told yesterday, pi is in Excel command is equal to pi, you have to write pi, you need not put the number. This is a unique thing, is equal to pi brackets and divided by 4. So, what does it mean? Pi is 180 degree, so pi by 4 is 45 degree. So, we want to rotate that triangle in 45 degree. So, here you put cos, or in this bracket you refer this cell where you have put this pi is equal to pi by 2. In any cell you put a value is equal to pi by 2, any cell. Okay. Just write pi bracket, first bracket close, and then slash, then by 4. So, it should appear something like 1.70 something, it will come. What is the value? Others? Him, you just check here, what is the pi
is equal to 0.7853.
Yeah, 0.78. Yes. So, this is this signifies the 45 degree. How will signify? You should know that whether it is 45 or not. How you will be knowing? For that, in the next cell you put this like that is equal to, you refer this cell 1. Suppose this is cell 1 into again pi bracket divided by 180. No, this is 180 and pi. You put this, you will get there 45, I think. You just refer C1 means this cell and then multiply it 180 and divide by pi as I told you.
So, essentially converting degrees to
Yes.
radians to degrees.
Radians to degrees. So, I should know that what angle it is moving.